Hello everyone. Assalamualaikum warahmatullahi wabarakatuh. May peace be upon you. Okay. So actually this video is the second video of the introduction for the gear. If you haven't watched the part 1, so please check the link in the description down below. Okay. So let's continue with the lecture. Okay, so when we want to create a gear, we need to make sure that the gear has a conjugate action. Okay, so what is conjugate action? So conjugate action is when surface roll, or slide, when they roll or slide against each other and produce constant angular velocity ratio, they are said to have conjugate action. So this one is very important to make sure that the gear will rotate smoothly. Okay, conjugate action is very important. Okay. So when we are in a conjugate action, the angular velocity ratio is inversely proportional to the ready to point P, with the pitch point, this one, so this is the relation of the gear here, the angular velocity ratio here is equals to this one, R, the radius, this one, okay. So how to make sure that our gear has a conjugate action, So the most common conjugate profile, is this one, involute. This one, involute profile. So what is involute profile? Okay, so if you see this one, so this is the involute line here. So actually this involute line here represents the shape of our tooth. This one, so this shape here, so this shape here is this one, involute profile here, so this part here, so how we can make this involute profile here, so let's look at this one here, it mentioned here it can be generated by unwrapping a string from a cylinder, keeping the string taut and tangent to the cylinder. Okay, how do they this one make this one? Okay, so first this one, if you see from A4 to B4, this line here, so actually this line here is the same length with from A0 to A4 to A0, this one. Okay, so first of all they will wrap, they will wrap A4 to A0 first, and then they will stretch the string here, they will stretch the string here so that the string will be tangent with this circle here, or we call it as the base circle here, this one here, after that they will mark this point here, and then same process with this one here from A3 to B3 has the same length of A3 to A0 here, so they wrap from A3 to A0 and then they unwrap the string here and make it tangent to point A3. So this is the point that they want to mark, and then the process continue with A2 and also A1. So when they combine all these point here, we can get this involute profile. So the base circle here will be different based on the size of the gear, which is why a larger base circle will have a different involute profile, with the smaller base circle of a gear. So if you look closely, if you have a time to have a two different size of a gear, please check the involute profile of the gear. It will be slightly different. So this one, how can an involute profile producing conjugate action? This one, so this is the base circle here. So this base circle here, this one, if we make a tangent, of this one here, so we can have a tangent point from this one, from A to B here. So this is the shape of our tooth. Okay, the gear tooth, this one, and also this one. So this is the shape of our gear tooth for the gear 2 here, and this is the shape of the tooth of the gear 1. Okay, so as you can see here, it will be slightly different. Okay, so this is how they will conjugate. Okay, so the next one is the gear layout. Okay, we have many lines or many circle right now. Okay, let's go through this layout one by one. Okay, so I mentioned earlier, when we want to create the involute profile, we need to have the base circle. So this is the base circle. Okay, this one, this line here. So this is the involute. This one, so this is the involute, and then this is the pitch point. Okay, pitch point is here. Okay, this one, the point there is the intersects point of this one, the line from the center of gear 1 to gear 2. If you look closely, base circle is slightly smaller than the pitch circle. It's not equal to pitch circle, different, okay, slightly smaller, and it is slightly bigger than the dedendum circle. Okay, slightly bigger. Okay, this one, okay, and this one is the addendum circle for gear, bottom gear, and also the upper gear here. Okay, and this is the radius. So radius here is the R1 here is the radius of the pitch circle. Okay, and this is the angular velocity. Okay, W2 here. And can you see this line here? Okay, the line that is this one, okay, there is tangent to both of these circle here, and tangent to both of the base circle of the upper gear and tangent to the base circle of the lower gear here. Okay, this line here. Okay, this line here is actually the line of action. So how can this line of action can be determined? Okay, let's take a look at this image here. Okay, at the gift here. Okay, let's take a look at this one. Okay, so when gear make contact, okay, as you can see here, okay, gear will make contact at a point only, a specific point only. So if we follow this point here, we will have this line here. Okay, so this is the line of action. This one, okay, this is the line of action. Okay, this one, okay, so let's go back, okay, to this one here. Okay, okay, we have here angle. This one here, this angle here, we call it as the pressure angle. Okay, the line of action, the angle between line of action and also the tangent line at the pitch point here. Okay, this one. So this is the angle. Okay. So I mentioned earlier, so this one here we have the pressure angle. Okay, so this is the line of action, or we can also simply say it as pressure line also. Okay. Okay, so that's all for the introduction of the topic gear. So please continue to watch my next lecture. Okay, see you again. Bye bye.